Settle into the Sleepy Mind channel, where tonight we will travel to the shores of Lake Maracaibo, one of the largest lakes in South America and home to millions of people living throughout the surrounding region. Together, we will discover why this remarkable corner of Venezuela experiences storms unlike anywhere else on the planet, how warm tropical waters, towering mountains, and shifting winds combine with astonishing precision to create an almost endless display of lightning, and why sailors once depended upon these glowing skies as a natural lighthouse. Along the way, we will explore the history of the lake, the indigenous communities who watched these storms long before written history, the explorers who struggled to explain them, and the scientists who continue searching for answers even today. If you enjoy videos like these, please like the video and subscribe to the channel. New videos are posted every week. For all night listening, explore the playlist filled with relaxing journeys through history, science, nature, and the world's lesser-known wonders. Another calm destination is always waiting to be explored. Now allow your breathing to settle into a slow and comfortable rhythm as you imagine yourself standing beside the peaceful shoreline of Lake Maracaibo, just as the final light of day slips behind the distant mountains. The warm tropical air feels heavy with moisture, the water lies almost perfectly still, and the last birds quietly disappear into the surrounding mangroves. For a few peaceful moments, the lake seems completely ordinary. Fishing boats rest gently upon the calm water, wooden homes built on stilts overlook the shoreline, and small villages prepare for another quiet evening beneath the fading sky. Then, almost without warning, a brilliant flash suddenly lights the horizon. A few seconds later, another follows, then another, until the distant clouds pulse continuously with white and violet light. Night has barely begun, yet the greatest electrical show on Earth is already underway. For someone witnessing Catatumbo Lightning for the very first time, the experience almost seems unreal. The clouds seem alive, constantly reshaping themselves as brilliant forks of electricity dance between them. Sometimes several bolts appear at once, branching outward like the roots of an ancient tree spreading across the heavens. The rhythm becomes almost hypnotic. Flash after flash unfolds with such regularity that it begins to feel less like an ordinary thunderstorm and more like a natural heartbeat pulsing above the lake throughout the night. The location of this extraordinary phenomenon makes it even more remarkable. Venezuela occupies the northern edge of South America, where the continent meets the warm waters of the Caribbean Sea. It is a country of remarkable diversity, stretching from tropical coastlines and broad river plains to dense rainforests, sweeping grasslands, and rugged mountain ranges. Covering more than 350,000 square miles, Venezuela is one of the larger nations in South America and is home to more than 28 million people. While many visitors know the country for Angel Falls, the highest uninterrupted waterfall on Earth, or for its vast oil reserves beneath Lake Maracaibo, another natural wonder quietly unfolds almost every evening above the same body of water. Unlike waterfalls or mountain peaks that remain visible throughout the day, Catatumbo Lightning belongs almost entirely to the darkness, revealing itself only after sunset, when the first towering storm clouds begin gathering above the lake. Lake Maracaibo itself is unlike many lakes found elsewhere in the world. Although commonly referred to as a lake, it is connected through the Strait of Maracaibo and the Gulf of Venezuela to the Caribbean Sea. allowing salt water and fresh water to mix in different parts of the basin. Covering thousands of square miles, it has served as the heart of western Venezuela for countless generations. Fishing communities have long depended upon its waters, while major cities developed along its shores as trade expanded throughout the region. The lake is surrounded by vast wetlands rich with wildlife, winding rivers carrying fresh water from distant mountains, and broad stretches of tropical vegetation that thrive in the warm, humid climate. During the day, the lake often appears calm and inviting, reflecting blue skies and drifting clouds across its broad surface. Few visitors would guess that after sunset, this peaceful landscape transforms into the setting for one of the most extraordinary atmospheric displays on Earth. The region surrounding Lake Maracaibo is shaped by geography that seems almost perfectly designed to create dramatic weather. To the west rise the towering Andes Mountains, whose snow-capped peaks stand in striking contrast to the warm tropical lowlands below. Additional mountain ranges curve around the southern and eastern edges of the basin, forming an enormous natural bowl that surrounds much of the lake. Throughout the day, sunlight heats the water and the nearby wetlands, filling the air with tremendous amounts of warmth and moisture. Gentle breezes carry that humid air across the lake, while cooler air gradually begins descending from the surrounding mountains as evening approaches. Most places experience these daily changes without attracting much attention. Here, however, the landscape encourages these different air masses to meet in almost exactly the right place, night after night, creating conditions unlike almost anywhere else on Earth. Long before meteorologists began studying atmospheric pressure or satellite images revealed the movement of tropical storms, people living along these shores already understood that the evening sky possessed an unusual rhythm. They did not calculate humidity levels or analyze electrical charges within towering storm clouds. They simply watched as darkness arrived, knowing that before long the heavens would almost certainly begin flashing once again. Children grew up seeing distant lightning so often that it became part of everyday life. Fishermen learned to judge the changing sky before leaving the shore. Travelers crossing the lake accepted the glowing horizon as a familiar companion during long nights upon the water. For countless generations, this extraordinary phenomenon became woven into the identity of the region itself, reminding everyone who lived there that nowhere else on Earth seemed quite like the shores of Lake Maracaibo. Tonight our journey is only beginning, because in this quiet corner of Venezuela, every mountain, every river, every warm breeze, and every drop of moisture rising from the lake contributes another piece to a natural puzzle that has fascinated explorers, sailors, scientists, and local communities for centuries. And as the tropical night grows darker above the calm waters of Lake Maracaibo, the sky continues flashing across the horizon, inviting us to discover why this extraordinary place has earned its reputation as the home of the lightning that never seems to stop. For thousands of years, the people living around Lake Maracaibo accepted these glowing skies as simply part of life. Long before weather stations, satellites, and atmospheric science offered explanations, the storms arrived with remarkable consistency, returning so often that they became woven into local culture. Imagine growing up in a village where the night horizon flashed almost every evening. Children would fall asleep with distant bursts of light illuminating the clouds beyond the lake. Fishermen returning home after sunset would steer their boats beneath skies that seemed alive with electricity. The indigenous peoples who lived around the lake long before European explorers arrived naturally developed their own explanations for the mysterious phenomenon. Like cultures throughout the world, they looked toward the natural forces surrounding them and searched for meaning in events that appeared beyond ordinary understanding. Endless flashes dancing across the heavens inspired stories of powerful spirits, ancestral guardians, and supernatural forces watching over the land. Although the details varied among different communities, the glowing skies became an important part of local tradition, passed from one generation to the next through stories shared around evening fires. These legends remind us that long before scientific instruments measured humidity or electrical charges, people were already observing nature with remarkable attention. They may not have understood the atmospheric processes involved, but they recognized that this place possessed something unique, something unlike any other landscape they had ever known. When European explorers first reached the region during the early years of exploration in South America, they encountered not only an immense tropical lake, but also a phenomenon that challenged their understanding of the natural world. Accounts written by sailors and explorers frequently described nights when the horizon seemed to flicker continuously with distant lightning. At first, some believed they were witnessing unusually powerful thunderstorms. Others assumed they had simply arrived during a particularly active weather season. Yet as days turned into weeks and the storms continued returning with astonishing regularity, many realized they had discovered something far more unusual. Reports gradually spread beyond Venezuela, describing a place where lightning seemed almost permanent, where the night sky glowed again and again above the waters of Lake Maracaibo with astonishing consistency. One of the reasons these reports attracted so much attention was because sailors quickly realized the storm served a practical purpose. Long before modern navigation systems guided ships with satellites and electronic charts, mariners depended upon the stars, the coastline, and visible landmarks to determine their position after sunset. Along much of the Caribbean coastline, darkness could make navigation difficult, especially on cloudy nights when familiar stars disappeared behind thick layers of cloud. Near Lake Maracaibo, however, nature often provided its own beacon. The distant flashes of Catatumbo Lightning could sometimes be seen from many miles away, repeatedly illuminating the horizon and allowing experienced sailors to identify the entrance to the lake even during the darkest nights. Over time, the phenomenon earned a fitting nickname, the Lighthouse of Maracaibo. Unlike a man-made lighthouse requiring keepers, fuel, or maintenance, this natural beacon operated through the extraordinary forces of the atmosphere itself, announcing the location of the lake night after night through brilliant flashes that reached far across the surrounding waters. Historical records even suggest that this remarkable natural lighthouse may have influenced important events. One of the most frequently repeated stories dates to the late 16th century, when an attempted nighttime attack on the city of Maracaibo was reportedly exposed by the constant flashes of lightning illuminating approaching ships. According to the traditional account, what should have been a stealthy approach under the cover of darkness instead became visible as repeated bursts of light revealed the vessels against the horizon. Whether every detail of the story unfolded exactly as later generations described remains difficult for historians to verify with complete certainty, but the legend has endured because it reflects a simple truth. The storms were so dependable that people came to rely upon them, and those brilliant flashes became more than a scientific curiosity. They became part of the history and identity of the region itself. While sailors admired the lightning from the open water, people living along the shoreline experienced something equally remarkable. Unlike the sudden arrival of thunderstorms familiar in many parts of the world, Catatumbo lightning often develops with an almost predictable rhythm. During the warmth of the afternoon, sunlight pours across the lake and surrounding wetlands, quietly preparing the atmosphere for what will happen after sunset. Moisture rises steadily into the air throughout the day, invisible to everyone below. The surface of the lake acts like an enormous reservoir of warmth, storing heat that will later help fuel the evening storms. As darkness gradually approaches, subtle changes begin unfolding high above the landscape. Air currents shift direction, temperatures slowly change, and the atmosphere becomes increasingly unstable. None of these transformations can be seen directly, yet together they prepare the conditions for one of the greatest electrical displays on Earth. From the shore, those first moments can seem almost magical. The western sky grows darker as the final glow of sunset fades beyond the mountains. A few distant clouds begin towering higher above the horizon, their upper edges catching the last traces of fading light before disappearing into the deepening blue of evening. For several peaceful minutes, everything remains still. Then, a single flash briefly illuminates the clouds from within. A second follows only moments later. Soon another appears farther across the horizon, then several more in rapid succession, until enormous sections of the sky pulse continuously with brilliant white light. The reflections shimmer across the calm waters of Lake Maracaibo, transforming the lake into a mirror that seems to capture the storm itself. For generations, people have traveled great distances hoping to witness this extraordinary display with their own eyes. Yet despite its growing reputation, Catatumbo lightning remains one of Earth's lesser-known natural wonders. It receives far less attention than famous waterfalls, volcanoes, or mountain ranges, even though the spectacle unfolding above Lake Maracaibo is unlike anything found elsewhere. Perhaps that is part of its enduring appeal. Hidden away in a quiet corner of Venezuela, far from the destinations most travelers immediately recognize, the atmosphere continues performing one of nature's most remarkable acts almost every night. The question that has fascinated people for centuries remains the same today as it was when the first indigenous communities watched the glowing horizon thousands of years ago. Why does it happen here, and why does it continue with such astonishing consistency, while so few other places on Earth experience anything quite like it? To answer that question, we have to look beyond the lightning itself and instead examine the remarkable geography surrounding Lake Maracaibo. Few natural phenomena are created by a single cause. More often, they emerge when many different conditions come together at exactly the right time and in exactly the right place. Catatumbo lightning is one of the finest examples of this principle. Remove almost any one piece of the puzzle, and the nightly storms would become far less frequent or might disappear altogether. It is the perfect meeting of landscape, climate, water, wind, and atmosphere that allows this extraordinary display to continue year after year. Nature has quietly assembled an enormous weather machine, and Lake Maracaibo sits at its very center. The shape of the land surrounding the lake is the first important clue. Looking at a map of northwestern Venezuela, Lake Maracaibo almost appears to rest inside a giant natural basin. To the west rise the towering Andes Mountains, whose highest peaks stretch thousands of feet into the sky. Along the southern edge stand additional mountain ranges, while lower hills and elevated terrain continue wrapping around much of the eastern side. Together, they form something resembling an enormous horseshoe surrounding the lake on three sides, leaving only a relatively narrow opening toward the Caribbean Sea in the north. This geography plays a crucial role, because mountains influence the movement of air just as surely as riverbanks influence the movement of water. They guide winds, block weather systems, and create areas where air naturally rises or descends. Around Lake Maracaibo, these surrounding mountains quietly help organize the atmosphere every single day. During daylight hours, the tropical sun pours immense amounts of energy onto the landscape. Venezuela lies close to the equator, meaning the sun remains high in the sky throughout much of the year. Unlike regions farther north or south, where seasons bring dramatic swings in temperature, the Maracaibo Basin remains consistently warm. The lake absorbs enormous quantities of solar energy during the day, while the surrounding wetlands, forests, and grasslands also heat rapidly beneath the tropical sunshine. As the surface warms, water slowly evaporates into the atmosphere. Every hour, countless tiny droplets leave the lake and surrounding marshes, becoming invisible water vapor carried upward into the humid air. This process seems gentle and almost insignificant while it is happening, yet by late afternoon, an astonishing amount of moisture has accumulated above the region, quietly storing the energy that will later fuel the evening storms. Lake Maracaibo itself contributes enormously to this daily cycle. Because water warms and cools more slowly than land, the lake acts as a vast reservoir of heat. Long after the sun begins setting, its broad surface continues releasing warmth into the atmosphere above. Covering thousands of square miles, the lake supplies far more moisture than a smaller body of water ever could. Every breeze moving across its surface gathers additional humidity before drifting inland or rising into the sky. The surrounding wetlands strengthen this effect even further. Dense vegetation, winding rivers, and shallow marshes continually add moisture to the already humid tropical air, creating an environment where the atmosphere becomes increasingly heavy with invisible water vapor. By itself, this moisture does not create lightning, but it provides one of the essential ingredients needed for powerful thunderstorms to develop. As evening approaches, another important change begins unfolding high above the landscape. Throughout the day, the mountain slopes surrounding the lake have also absorbed the sun's warmth. Once darkness arrives, however, those elevated regions cool more rapidly than the broad lake below. Cooler, denser air gradually begins flowing downhill through valleys and mountain passes toward the warmer basin surrounding Lake Maracaibo. At nearly the same time, the warm, moisture-filled air above the lake continues rising because it remains lighter than the cooler air descending from the mountains. Eventually, these different air masses meet. Warm tropical air surges upward, while cooler mountain air pushes downward and inward. Their collision creates powerful upward motion within the atmosphere, forcing enormous volumes of moist air higher and higher into the sky. As that rising air climbs, something remarkable begins to happen. Temperatures decrease rapidly with altitude, causing the invisible water vapor to cool and condense into tiny droplets that gather together as clouds. At first they appear as ordinary white clouds drifting across the evening sky, but the upward motion does not stop. Warm air continues rising from below, feeding the growing cloud with fresh moisture and energy. The cloud expands vertically, rather than simply spreading outward, reaching astonishing heights that can extend many miles above the Earth's surface. These immense towers are known as cumulonimbus clouds, the giants of the atmosphere, and the same cloud type, responsible for the world's most powerful thunderstorms. Viewed from a distance, they resemble enormous mountains suspended in the sky, their broad upper surfaces spreading outward into the familiar anvil shape recognized by meteorologists around the world. Inside these towering clouds, conditions become increasingly turbulent. Powerful updrafts carry tiny droplets of water and small ice crystals rapidly upward, while heavier particles begin falling back toward the lower portions of the storm. Countless collisions occur every second as ice, water droplets, and soft hailstones repeatedly crash into one another within the swirling air currents. Although invisible from the ground, these tiny impacts gradually separate electrical charges throughout different regions of the cloud. Lighter, positively charged particles tend to accumulate near the upper portions, while heavier, negatively charged particles gather lower down. The imbalance steadily increases until the atmosphere can no longer contain the enormous electrical difference developing inside the storm. Nature has quietly spent hours building this invisible tension, and eventually it must be released. That release arrives in the form of lightning. A brilliant electrical discharge suddenly races through the atmosphere at incredible speed, equalizing the imbalance that has slowly developed inside the cloud. Almost instantly, the surrounding air is heated to temperatures approaching 5 times hotter than the surface of the sun. The air expands explosively, producing the familiar sound we know as thunder. Yet above Lake Maracaibo, this process does not occur only once. The atmosphere continues feeding the storm with fresh warmth and moisture, allowing new electrical charges to build again and again. It is this steady replenishment of energy that helps explain why Catatumbo Lightning can continue for so many hours, while thunderstorms in many other parts of the world weaken and fade much more quickly. What makes Catatumbo Lightning especially fascinating is that it demonstrates how delicately balanced Earth's atmosphere really is. We often think of weather as something chaotic, with storms appearing almost at random across the landscape. Yet above Lake Maracaibo, scientists have discovered a system that behaves with surprising regularity. The ingredients arrive in nearly the same sequence day after day. The tropical sun warms the lake, moisture rises steadily into the air, evening allows cooler mountain winds to descend toward the basin. Towering storm clouds begin building over the same general region. Electrical charges separate within those clouds until the sky finally releases its stored energy in brilliant flashes of lightning. Even with this growing scientific understanding, researchers remain careful about claiming they have solved every mystery surrounding the storms. Weather is one of the most complex systems on our planet, influenced by countless variables interacting at the same time. Temperature, humidity, wind direction, atmospheric pressure, seasonal rainfall, and even distant climate patterns all play important roles. Scientists continue collecting data using weather balloons, radar, satellites, and instruments placed throughout the region, because every year provides another opportunity to better understand how these remarkable storms develop. Rather than viewing Catatumbo Lightning as a mystery that has already been completely solved, modern researchers see it as a natural laboratory where the atmosphere continues teaching new lessons about the remarkable forces shaping weather across our planet. One question that has received considerable attention involves the wetlands surrounding Lake Maracaibo. These broad marshes support enormous amounts of plant life, and as leaves, grasses, and other organic materials naturally decompose, they release gases into the atmosphere. Several years ago, some scientists proposed that methane rising from these wetlands might contribute to the electrical activity by influencing the atmosphere above the lake. It was an intriguing idea because the region contains extensive wetlands rich in organic material. However, as additional studies were carried out, researchers found stronger evidence supporting the role of geography, moisture, wind patterns, and atmospheric instability as the primary drivers behind the phenomenon. While the exact influence of naturally occurring gases continues to be studied, the scientific consensus today places far greater importance on the unique combination of mountains, tropical warmth, abundant humidity, and daily air circulation that make the storms possible. It serves as a reminder that science continually refines its understanding as new evidence becomes available. The amount of lightning produced during these storms is truly astonishing. Some nights remain relatively quiet, while others seem almost impossible to count, as flashes ripple continuously across enormous thunderclouds. From a distance, individual lightning bolts often blend together into a nearly constant flickering glow, stretching across the horizon. It is this incredible frequency that separates Catatumbo lightning from ordinary thunderstorms. Most storms eventually exhaust the energy available to them and gradually weaken. Here, the atmosphere repeatedly renews that energy, allowing fresh electrical charges to build almost as quickly as previous ones have been released. Watching the sky over Lake Maracaibo can feel less like observing isolated lightning strikes, and more like witnessing an endless conversation taking place within the clouds themselves. Many visitors are surprised to learn that the storms often remain far enough away for the experience to feel peaceful rather than frightening. Boat tours operating on portions of Lake Maracaibo generally observe the storms from safe distances, allowing visitors to watch the glowing horizon while remaining well outside the most intense weather. From that vantage point, the clouds appear almost like enormous illuminated mountains rising into the tropical night. Reflections shimmer across the quiet water, doubling the beauty of the spectacle as the lake mirrors each flash overhead. Because sound travels much more slowly than light, thunder may arrive many seconds after the lightning, or sometimes remain too distant to hear clearly at all. The result is an experience unlike the violent thunderstorms many people know from home. Instead of feeling sudden and chaotic, Catatumbo lightning often appears graceful, rhythmic, and strangely calming when viewed from afar. Of course, the storms themselves remain incredibly powerful natural events. Each lightning bolt represents an enormous electrical discharge carrying tremendous amounts of energy. Although the flashes last only fractions of a second, they briefly heat the surrounding air to temperatures approaching 30,000 degrees Celsius, causing the air to expand explosively and generate thunder. Slow-motion cameras have revealed that what appears to be a single lightning strike is often made up of multiple rapid return strokes traveling along nearly the same path in quick succession. Human eyes merge these events into one brilliant flash, but specialized cameras expose a far more intricate process unfolding within the storm. Every lightning bolt tells the story of countless tiny collisions between ice particles and water droplets that occurred moments earlier inside the towering cumulonimbus cloud. The beauty we admire from a distance is the visible result of extraordinary atmospheric forces working together on a scale almost impossible to imagine. Even after centuries of observation, there is still something deeply mesmerizing about the rhythm of these storms. Flash after flash spreads silently across the clouds, while warm tropical air continues rising from the lake below. The mountains remain dark silhouettes surrounding the basin, quietly guiding the winds exactly as they have for countless generations. The lake continues releasing moisture into the evening air, and the atmosphere patiently rebuilds the electrical energy that will soon be released once again. It is a cycle that has repeated itself through the lives of indigenous communities, early explorers, generations of fishermen, and modern scientists alike. Night after night, the same remarkable forces come together above Lake Maracaibo, creating a display so dependable that it has earned its place among the greatest natural wonders of the world, even if many people beyond Venezuela have never had the opportunity to witness its extraordinary beauty. As remarkable as Catatumbo Lightning is, it does not occur with exactly the same intensity every night of the year. Like every weather system on Earth, it responds to the changing rhythm of the seasons. Venezuela does not experience spring, summer, autumn, and winter in the same way that countries farther from the equator do. Instead, much of the region follows a pattern of wetter and drier seasons, each influencing the atmosphere in different ways. During the wetter months, moisture becomes even more abundant across Lake Maracaibo and the surrounding wetlands. Warm air rises more easily, thunderstorms develop more frequently, and the familiar flashes often become especially intense. During drier periods, however, the atmosphere contains less available moisture, and the nightly displays may become less frequent or briefly disappear before gradually returning once conditions improve. Even one of the world's most dependable lightning storms still follows the changing pulse of nature. These seasonal variations have provided scientists with valuable opportunities to study the phenomenon in greater detail. By comparing years with especially active storms to years when lightning became less frequent, researchers have gained a deeper understanding of how sensitive the system is to even small changes in temperature, humidity, and regional weather patterns. No single ingredient controls the storms entirely. Instead, Catatumbo lightning depends upon a delicate balance maintained by many different parts of the environment working together. If prolonged drought reduces the amount of moisture rising from the lake and wetlands, storm activity may decline. If shifting wind patterns alter how cool mountain air flows into the basin, the timing and strength of the thunderstorms may also change. The atmosphere behaves much like a finely tuned orchestra, where every instrument contributes to the final performance. Remove one section, and the music continues, but it no longer sounds quite the same. Modern technology has allowed scientists to observe these storms from perspectives that earlier generations could never have imagined. High above the Earth, satellites circle the planet day and night, recording lightning activity across entire continents. Rather than relying solely on observers standing along the shoreline, researchers can now compare storms occurring around the globe almost simultaneously. These space-based observations have confirmed what local communities already understood through centuries of experience. The skies above Lake Maracaibo consistently rank among the most active lightning regions anywhere on Earth. From hundreds of miles above the atmosphere, satellites detect enormous concentrations of electrical activity returning to this same region again and again, providing powerful evidence that Catatumbo lightning is not simply an occasional weather curiosity, but one of the planet's most extraordinary atmospheric phenomena. Satellite observations have also revealed how dynamic Earth's atmosphere truly is. At any given moment, thousands of thunderstorms are active somewhere across the globe. Lightning flashes over tropical rainforests, across broad grasslands, above mountain ranges, and within powerful ocean storms. Yet even among this worldwide display of electrical activity, Lake Maracaibo continues to stand apart. Many regions experience intense thunderstorms during particular seasons, but relatively few maintain such a reliable concentration of lightning over the same location year after year. This remarkable consistency is one of the reasons atmospheric scientists remain so interested in the region. By understanding why this natural system functions so effectively, they gain insights that may improve weather forecasting and deepen our understanding of how geography influences climate throughout the world. Of course, lightning is far more than a spectacular display of light across the evening sky. It also plays an important role within Earth's natural systems. Every electrical discharge releases enormous amounts of energy into the atmosphere, triggering chemical reactions that help convert atmospheric nitrogen into forms that eventually become available to plants. Nitrogen is one of the essential building blocks of life, required for the growth of leaves, stems, roots, and countless biological processes within living organisms. Although most of the nitrogen surrounding our planet exists as a gas that plants cannot use directly, lightning helps transform a small portion of it into compounds that rainfall carries into the soil. There, the nutrients become available to forests, wetlands, grasses, and countless other forms of vegetation. In this way, every lightning storm contributes, however modestly, to the ongoing cycles that support life across the natural world. This connection between lightning and plant growth has fascinated scientists for generations because it demonstrates how deeply interconnected Earth's systems truly are. The storms above Lake Maracaibo are not isolated events occurring separately from the surrounding landscape. They are part of a much larger cycle linking sunlight, evaporation, atmospheric circulation, rainfall, soil chemistry, plant life, and the countless organisms depending upon healthy ecosystems. Warm tropical waters provide the moisture that fuels the storms. The storms release rain that nourishes surrounding forests and wetlands. Lightning contributes to natural nutrient cycles that support plant growth, while those same wetlands continue supplying moisture back into the atmosphere. Round and round the cycle continues, each part quietly supporting the next in a remarkable demonstration of nature's balance. Visitors who witness Catatumbo Lightning often describe something unexpected. Rather than remembering only the flashes themselves, many recall the atmosphere surrounding the experience. The tropical night feels warm and still. Gentle waves lap quietly against the sides of small boats. Insects continue their nightly songs from the nearby wetlands, almost unaware of the extraordinary spectacle unfolding above them. Occasionally, the silhouette of a distant bird crosses the glowing clouds before disappearing once more into the darkness. The lake reflects each burst of light so clearly that it can seem as though another storm exists beneath the water, perfectly mirroring the one above. Between the flashes, the stars briefly return, before disappearing again behind another brilliant pulse of white light. The experience is both peaceful and awe-inspiring at the same time, reminding every visitor that some of the world's greatest natural wonders are not found in silence alone, but in the remarkable rhythms through which nature reveals its extraordinary power. While the lightning is undoubtedly the star of the story, Lake Maracaibo itself deserves just as much attention. Without the lake, the surrounding mountains, and the tropical climate working together, Catatumbo Lightning would almost certainly not exist in its present form. Stretching across more than 5,000 square miles, Lake Maracaibo has shaped the lives of the people living along its shores for thousands of years. It provides transportation, supports fishing communities, influences local weather, and serves as one of the defining geographical features of western Venezuela. Looking across its broad waters during daylight, it is difficult to imagine that the same peaceful surface will later become the stage for one of the greatest electrical displays on Earth. The transformation from calm afternoon to brilliant nighttime spectacle is so complete that it almost feels as though the lake possesses two entirely different personalities, one belonging to the quiet hours of daylight and the other awakening only after the sun has disappeared beyond the mountains. The communities surrounding the lake have always adapted to this unique environment. Fishing remains an important way of life for many families, with generations learning the rhythms of the water just as carefully as earlier generations did before them. Boats leave the shoreline during daylight while the tropical sun shines overhead, returning later as evening begins settling across the basin. Along portions of the shoreline, houses stand on wooden stilts extending above the shallow water, creating scenes that have become closely associated with the region for centuries. Some historians even believe that these stilt villages inspired the name Venezuela itself. When early European explorers first arrived, they reportedly saw homes built above the water that reminded them of the famous canals and buildings of Venice, leading them to describe the region as Little Venice, a name that gradually evolved into Venezuela. Whether every detail of that story unfolded exactly as tradition suggests, the image remains a fitting reminder that life around Lake Maracaibo has always been closely connected to the water. As darkness approaches, daily routines gradually slow while the atmosphere quietly prepares for another remarkable evening. The warm air remains heavy with humidity, and gentle breezes drift across the broad surface of the lake. Birds that spent the day searching for food begin returning to sheltered nesting places among the surrounding wetlands. Herons stand motionless along the shallow shoreline, while egrets and ibises settle into the reeds before night fully arrives. Fish continue moving beneath the calm surface, and insects fill the evening air with a steady chorus of sound. At first glance, the natural world appears almost completely ordinary. Yet high above, invisible changes are already unfolding. Moisture continues rising from the lake, mountain air slowly descends into the basin, and towering clouds begin building beyond the horizon. The wildlife carries on with its nightly routines, almost as though the coming display of lightning is simply another familiar part of the landscape. The wetlands surrounding Lake Maracaibo are among the richest ecosystems in northern South America. Rivers flowing down from the surrounding mountains spread into broad marshes filled with reeds, mangroves, and aquatic vegetation before reaching the lake itself. These wetlands provide important habitat for countless species of birds, fish, reptiles, amphibians, and insects. During the rainy season, the landscape becomes especially vibrant as fresh water flows into the basin and new plant growth spreads across the marshes. Every living organism contributes in some way to the remarkable balance of the ecosystem. Plants release moisture into the atmosphere through a process known as transpiration, while open water continually evaporates beneath the tropical sun. Together, these natural processes help maintain the humid environment that plays such an important role in fueling the nightly thunderstorms. The beauty of Catatumbo Lightning cannot be separated from the health of the landscape surrounding it, because the storms themselves are born from the unique interaction between water, vegetation, mountains, and atmosphere. It is also impossible to speak about Lake Maracaibo without acknowledging its importance to Venezuela's modern history. Beneath portions of the lake lie some of the country's largest petroleum reserves, resources that transformed the surrounding region during the 20th century. Oil production brought economic development, expanded cities, and increased industrial activity along the shoreline. Yet despite these dramatic changes brought by human industry, the lightning continued appearing above the lake almost as reliably as it always had. Night after night, while ships crossed the water and communities continued growing along the shore, the atmosphere quietly repeated the same remarkable cycle it had followed for centuries before the first drilling platforms ever appeared. The storms served as a gentle reminder that even as human history changed the landscape in many ways, the natural forces shaping Catatumbo Lightning remained astonishingly persistent. Scientists have occasionally observed that the intensity of the phenomenon varies from year to year, and there have even been periods when the lightning temporarily became less active than usual. One of the most notable examples occurred during a severe drought in the early 21st century, when unusually dry conditions reduced storm activity for a time. Some observers wondered whether the famous lightning might be disappearing altogether. Yet as wetter conditions gradually returned, so did the storms. The glowing horizon once again became a familiar sight above Lake Maracaibo, reinforcing the understanding that the phenomenon depends upon a careful balance of moisture, temperature, and atmospheric circulation. These temporary changes have provided researchers with valuable opportunities to better understand the environmental conditions supporting the storms, while also reminding us that even the most dependable natural wonders remain closely connected to the changing rhythms of climate and weather. Today, Catatumbo Lightning continues attracting scientists, photographers, weather enthusiasts, and curious travelers from around the world. Some arrive hoping to capture the perfect photograph of brilliant lightning reflected across the still waters of the lake. Others come simply to witness a place they once believed could only exist in stories. Although modern science has explained much about how these storms develop, the emotional experience of witnessing them remains unchanged. There is still something profoundly moving about watching the atmosphere display its extraordinary power with such beauty, regularity, and grace, reminding us that even in an age of satellites and advanced technology, our planet continues to produce natural spectacles capable of leaving us completely speechless. One of the reasons Catatumbo Lightning continues fascinating scientists is because it illustrates how local geography can influence global scientific understanding. Meteorologists often study hurricanes, tornadoes, blizzards, and other powerful weather systems because they affect large populations across wide areas. Catatumbo Lightning is different. It is highly localized, occurring within a relatively small part of northwestern Venezuela, yet it demonstrates atmospheric processes that are relevant far beyond the shores of Lake Maracaibo. By carefully observing why thunderstorms become so unusually persistent here, researchers gain a better understanding of how moisture, terrain, and atmospheric circulation interact in many other parts of the world. The storms above Lake Maracaibo have therefore become more than a regional curiosity. They serve as one of nature's most remarkable outdoor laboratories, where the atmosphere repeatedly performs the same extraordinary experiment night after night. Advances in technology have transformed the way scientists observe these storms. Decades ago, researchers depended largely upon eyewitness accounts, weather stations, and occasional aircraft observations to understand what was happening above the lake. Today, sophisticated satellites orbiting hundreds of miles above the Earth continuously monitor lightning activity across the globe. Sensitive instruments can detect individual lightning flashes, measure their frequency, estimate their location, and compare activity between different continents with remarkable precision. This constant stream of information has confirmed that the Catatumbo region consistently ranks among the most electrically active places on the planet. Ground-based instruments have become equally important. Modern weather radar allows researchers to examine the internal structure of thunderstorms in ways that would have seemed impossible only a few generations ago. Powerful radar beams pass through storm clouds, revealing areas of intense rainfall, strong updrafts, and regions where ice particles and water droplets collide most vigorously. Weather balloons launched into the atmosphere measure temperature, humidity, air pressure, and wind speed at different altitudes, helping scientists understand how conditions change from the surface of the lake to the upper reaches of the storm clouds. Each measurement adds another piece to the puzzle, allowing researchers to refine computer models that simulate how Catatumbo lightning develops. Although the overall picture has become much clearer, the atmosphere still contains countless small interactions that continue challenging even the most advanced scientific models. One particularly interesting area of research involves the timing of the storms. Visitors sometimes imagine that lightning flashes continuously throughout the entire day and night, but the phenomenon follows a much more predictable rhythm. Most activity develops after sunset or during the nighttime hours, when the contrast between the warm lake and the cooling mountain slopes becomes greatest. During daylight, the atmosphere quietly prepares for what is to come. Moisture steadily accumulates, warm air continues rising, and energy gradually builds within the basin. As evening arrives, cooler air descending from the surrounding mountains strengthens the upward movement of the warm, humid air above the lake, allowing thunderstorms to develop rapidly. This daily cycle repeats with such regularity that local residents often know roughly when the first flashes are likely to appear. It is another example of how closely the storms remain tied to the natural rhythm of the landscape itself. Although Catatumbo Lightning is famous for its remarkable persistence, it is important to remember that no two nights are ever exactly the same. Some evenings produce only scattered flashes spread across distant clouds, while others fill nearly the entire horizon with almost continuous electrical activity. Weather systems arriving from the Caribbean, seasonal rainfall patterns, and subtle changes in regional wind circulation all influence the strength of the storms from one night to the next. This variation is one reason scientists continue returning to the region year after year. Every storm provides another opportunity to compare observations, test predictions, and improve our understanding of one of Earth's most extraordinary weather phenomena. Nature never repeats itself with perfect precision, yet it often follows recognizable patterns that reward careful observation over long periods of time. For the people who call this region home, however, Catatumbo Lightning is more than an object of scientific study. It is part of the identity of the landscape itself. Generations have grown accustomed to seeing the distant horizon glow after sunset, just as people elsewhere might expect to hear waves along an ocean shoreline or watch snow settle across distant mountains during winter. Visitors may stand in amazement at the endless flashes, but local communities have lived alongside this remarkable phenomenon for centuries. The storms have become part of local traditions, regional pride, and the unique character of Western Venezuela. They serve as a daily reminder that some of the world's most extraordinary natural wonders are not isolated events that happen only once in history. Instead, they continue unfolding quietly within the lives of ordinary people, becoming such a familiar part of everyday experience that those living nearby sometimes forget just how astonishing they truly are, until they see them again through the eyes of someone visiting for the first time. Over the years, photographers have traveled from around the world, hoping to capture the perfect image of Catatumbo Lightning. Unlike photographing a single lightning strike during an ordinary thunderstorm, where success often depends upon patience and good fortune, Lake Maracaibo offers opportunities that seem almost unbelievable. During especially active nights, flashes occur so frequently that cameras have repeated chances to record the brilliant electrical displays illuminating the clouds above the lake. Long exposure photography has revealed scenes that appear almost dreamlike. White branches of lightning spread across towering storm clouds, while their reflections shimmer on the dark surface of the water below. The surrounding landscape remains peaceful and still, creating a striking contrast between the quiet lake and the extraordinary energy unfolding overhead. Many of the world's most famous photographs of lightning have been taken here, not because the bolts themselves are necessarily larger than elsewhere, but because nowhere else offers such a reliable opportunity to witness them. Even experienced meteorologists often describe the first sight of Catatumbo Lightning as unforgettable. After years spent studying weather maps, satellite imagery, and atmospheric models, finally standing beside Lake Maracaibo brings those scientific diagrams to life. Concepts that exist only as numbers on computer screens suddenly become visible in the towering storm clouds overhead. Warm, humid air can almost be felt rising from the lake. Mountain silhouettes outline the basin where cooler air begins its evening descent. For scientists, the experience is both emotional and educational. They are not simply observing a thunderstorm. They are watching one of the most remarkable examples of atmospheric physics unfolding naturally before their eyes. Although lightning always requires caution, the Catatumbo region has also become a destination for nature tourism. Experienced local guides choose established viewing routes, monitor conditions, and adjust plans when the weather becomes unsafe. Small boats glide across the calm evening water as darkness slowly settles over the basin. Engines become quiet, conversations soften, and everyone gradually turns their attention toward the distant horizon. Then the first flashes begin. At first they seem isolated, separated by long pauses, but before long the rhythm increases until the clouds pulse repeatedly with brilliant light. Many visitors later describe the experience not as frightening, but as deeply peaceful. Watching the storms from a safe distance allows them to appreciate the immense beauty of the atmosphere without feeling threatened by its power. The wildlife surrounding Lake Maracaibo appears equally accustomed to these nightly displays. Fish continue swimming beneath the surface, while insects fill the humid evening air with their steady chorus. Frogs call from the wetlands, birds settle into sheltered trees, and countless nocturnal animals begin their nightly routines beneath skies that brighten again and again throughout the darkness. Researchers have long wondered how generations of wildlife have adapted to living beneath one of the most electrically active skies on Earth. The natural rhythms of feeding, nesting, and migration continue much as they always have, reminding us that these storms have been part of the landscape for far longer than any living creature now inhabiting the region. One particularly beautiful feature of Catatumbo Lightning is the way the clouds themselves seem to change character throughout the night. Early in the evening, individual towers often stand out clearly against the fading twilight, their upper edges catching the last hints of sunlight before darkness fully arrives. As the hours pass, the clouds merge into enormous storm complexes, stretching across broad sections of the horizon. Each flash briefly reveals new details hidden within their towering forms. Sometimes delicate branching bolts spread sideways through the clouds like glowing roots. At other moments, broad sheets of light illuminate the entire storm from within, exposing countless layers of swirling vapor before darkness gently returns once more. The display is never exactly repeated. Every flash reveals a slightly different view of the atmosphere, making the storm seem almost alive as it constantly reshapes itself throughout the night. The storms possess both predictability and surprise. Every evening becomes a unique performance created by the atmosphere itself. The mountains remain the same, the lake remains the same, and the warm tropical air continues rising just as it has for centuries. Yet the electrical display unfolding above them is always new. It is this perfect balance between familiarity and constant change that makes Catatumbo Lightning feel less like an ordinary weather event and more like a living work of art, painted across the skies of Venezuela night after night. As the years have passed, Catatumbo Lightning has become far more than a remarkable weather phenomenon. It has grown into one of Venezuela's greatest natural symbols, representing the extraordinary relationship between the country's geography and the powerful forces of its atmosphere. Artists have painted the glowing skies. Photographers have devoted countless nights to capturing the endless flashes. Writers have described the storms with a mixture of science and wonder, and generations of local families have watched the horizon brighten almost every evening. Unlike monuments built by human hands, this landmark exists entirely through nature itself. No walls were constructed, no towers were raised, and no machines were built to create the spectacle. Instead, mountains, tropical air, warm water, and invisible winds combine every night to produce a display that has continued for centuries without interruption. One reason the phenomenon has endured in the public imagination is because it challenges our expectations about what lightning should be. For many people, thunderstorms are brief visitors. Dark clouds gather, rain falls heavily for an hour or two, thunder echoes across the landscape, and before long blue skies begin returning. Catatumbo Lightning follows a very different rhythm. Here, the atmosphere behaves almost as though it has developed a nightly routine. The storms often build after sunset, continue for hours, then gradually weaken as morning approaches, only to repeat the cycle again on another evening. This dependable pattern transforms lightning from an occasional surprise into a familiar companion of the tropical night. It is one of the few places on Earth where people can plan a journey specifically to watch lightning, confident that nature will likely provide the performance they have traveled so far to witness. The scale of the display also continues to amaze first-time visitors. Standing beside the lake, it quickly becomes clear that these are not isolated flashes appearing here and there across the horizon. Entire sections of the sky seem to pulse continuously with light. At times, several different parts of the storm illuminate almost simultaneously, creating enormous glowing curtains stretching across the distant clouds. One flash fades, only to be replaced by another moments later. Occasionally, the lightning branches outward in intricate patterns, while at other times broad sheets of light spread through the clouds themselves, making the entire storm appear to glow from within. The sheer number of flashes creates an experience unlike almost any other thunderstorm on Earth. Rather than waiting patiently for the next strike, observers often find themselves surrounded by an almost continuous rhythm of brilliant light unfolding high above the lake. Despite this incredible energy, the storms also possess a surprising elegance. There is no sense of chaos when viewed from a safe distance. Reflections shimmer gently across the surface of Lake Maracaibo, while the surrounding landscape remains remarkably peaceful. The contrast is striking. Above, unimaginable electrical forces race through clouds reaching miles into the atmosphere. Below, the lake remains calm enough to mirror each burst of light, as though it were quietly participating in the performance. This balance between immense power and quiet beauty is one of the qualities that makes Catatumbo Lightning so unforgettable. It reminds us that nature's greatest spectacles are often not simply dramatic, they are beautiful as well. As scientists continue studying the storms, they also recognize that Catatumbo Lightning offers valuable insight into Earth's changing climate. Because the phenomenon depends upon such a delicate balance of temperature, moisture, wind, and geography. Long-term observations may help researchers understand how regional weather patterns respond to broader environmental changes. Careful records collected over many decades allow scientists to compare storm frequency, seasonal timing, and atmospheric conditions from year to year. While no single location can explain every aspect of global climate, Lake Maracaibo provides one of the world's most consistent natural laboratories for examining how the atmosphere behaves under remarkably stable geographical conditions. Every season adds another chapter to an ongoing scientific record that may prove increasingly valuable in the years ahead. Yet perhaps the greatest lesson offered by Catatumbo Lightning has little to do with weather instruments or scientific measurements. Instead, it reminds us that our planet still possesses places capable of inspiring genuine wonder. In an age when satellites photograph every corner of the Earth and maps seem to leave few mysteries unexplored, it is comforting to know that remarkable natural spectacles continue unfolding beyond the awareness of much of the world. Hidden within the warm tropical nights of northwestern Venezuela, the sky still erupts with light, almost exactly as it did when the first indigenous communities watched the glowing horizon thousands of years ago. Explorers stood in amazement beneath these same storms. Sailors relied upon them as a beacon. Scientists continue searching for deeper understanding. And tonight, as another evening settles over Lake Maracaibo, the atmosphere quietly prepares to perform one of Earth's greatest natural wonders once again, reminding us that some of the most extraordinary places on our planet reveal their greatest beauty only after darkness falls. The longer researchers observe Catatumbo Lightning, the more they appreciate that its true significance lies not in a single spectacular storm, but in its extraordinary consistency across generations. Most remarkable weather events become memorable precisely because they are rare. A powerful hurricane may pass through only once in many years. An unusually severe blizzard becomes part of local history because it happens so infrequently. Catatumbo Lightning follows a completely different pattern. Its wonder comes from repetition. Night after night, season after season, decade after decade, the atmosphere continues producing one of the most reliable displays of lightning anywhere on Earth. It is this remarkable dependability that has allowed generations of indigenous communities, fishermen, explorers, scientists, and travelers to share essentially the same experience despite living centuries apart. They all look toward the same glowing horizon and witness the same remarkable dance of light unfolding above Lake Maracaibo. This consistency has earned the phenomenon recognition far beyond Venezuela itself. Meteorologists studying global lightning frequently include Catatumbo among the most important locations for understanding atmospheric electricity. Geography students often encounter the region when learning how mountains, lakes, and climate interact to shape local weather systems. Nature photographers dream of witnessing its glowing skies, while travelers searching for unusual destinations place Lake Maracaibo high on their lists of places they hope to visit someday. Yet despite this growing international recognition, Catatumbo Lightning remains surprisingly untouched by mass tourism compared with many of the world's famous natural landmarks. Visitors who make the journey still find a place where nature remains the main attraction, where the atmosphere performs its nightly spectacle without grand viewing platforms or elaborate displays. The storms need no introduction because they have been introducing themselves every evening for countless generations. There is also something deeply humbling about realizing how small humanity appears beneath these immense storm clouds. Standing beside the lake after sunset, watching lightning spread across clouds rising miles into the atmosphere, it becomes impossible not to appreciate the enormous forces constantly shaping our planet. The energy released during each flash has been quietly building throughout the day as sunlight warmed the lake. Moisture evaporated into the humid air, and invisible winds carried that energy upward into the towering clouds. Every brilliant burst of light represents the release of processes that began hours earlier, guided by geography that has remained largely unchanged for millions of years. Human history feels brief by comparison. Civilizations have risen and fallen, while the mountains continued directing the winds, and Lake Maracaibo continued releasing moisture into the evening sky. The storms remind us that many of Earth's greatest natural systems operate on timescales far beyond our own lives, patiently following rhythms established long before anyone gave them a name. Even the darkness itself seems to play an important role in the experience. During daylight, the landscape surrounding Lake Maracaibo is undeniably beautiful, with broad stretches of shimmering water framed by distant mountains and lush tropical vegetation. Yet it is only after the sun disappears that the region reveals the phenomenon for which it has become famous. The night transforms into a stage where every flash briefly reveals details hidden only moments before. Towering cloud formations appear and vanish almost instantly. Reflections dance across the quiet lake before fading back into darkness. The surrounding mountains emerge as dark silhouettes against glowing skies, then disappear once more into the tropical night. It is a performance that depends as much upon darkness as it does upon light, reminding us that some of nature's greatest spectacles cannot be fully appreciated until the world grows still and the day comes to an end. Perhaps that is why Catatumbo Lightning feels so perfectly suited to a quiet evening of reflection. Unlike many natural wonders that demand movement and activity, this one invites stillness. There is nothing to climb, no summit to reach, and no rushing river to chase downstream. Instead, the experience asks only that we sit quietly beside the water, breathe the warm tropical air, and watch the atmosphere perform one of its oldest nightly rituals. Every flash tells the same timeless story of warm air rising, cool mountain winds descending, towering clouds growing into the darkness, and electrical energy finally finding its release across the heavens. It is a story that has been unfolding over Lake Maracaibo for countless generations, and one that continues tonight exactly as it did long before the first explorers, the first scientists, or even the first written histories ever recorded its existence. As our understanding of Catatumbo Lightning has grown, so too has our appreciation for how many different parts of the natural world must work together to sustain it. The sun warms the waters of Lake Maracaibo throughout the day. Moisture quietly rises into the atmosphere. Wetlands surrounding the lake add still more humidity to the already tropical air. Gentle breezes carry that moisture across the basin, while the surrounding mountains patiently wait for evening to arrive. As darkness falls, cooler air begins flowing down their slopes, meeting the warm air rising from below. Towering cumulonimbus clouds climb higher and higher into the sky, until the atmosphere can no longer contain the electrical energy building inside them. Only then does the lightning finally appear, revealing the invisible work that nature has been performing since sunrise. Every flash is the visible conclusion of a process that began long before the first clouds even formed. This remarkable chain of events reminds us that nothing in nature exists entirely on its own. The mountains influence the winds shape the clouds, the lake provides warmth and moisture, the wetlands enrich the atmosphere with additional humidity, the tropical climate supplies the energy that keeps the entire system moving. Remove any one of these ingredients, and the nightly display would almost certainly become weaker or disappear altogether. Catatumbo Lightning is therefore not simply the story of lightning. It is the story of an entire landscape working together with astonishing precision. Geography, climate, water, and atmosphere combine in perfect balance to create a phenomenon that continues astonishing scientists despite centuries of careful observation. It is also remarkable to consider how dependable this natural process has remained despite the passage of time. Generations of people have lived beside Lake Maracaibo, watching these glowing skies become part of the rhythm of everyday life. Parents who once watched the distant flashes, as children later shared the same view with their own sons and daughters. Fishermen learned to recognize the familiar glow on the horizon, just as their grandparents had before them. Travelers arriving for the first time often experience the same amazement described by explorers centuries earlier. Although technology has transformed nearly every aspect of modern life, the atmosphere above Lake Maracaibo continues following patterns established long before human civilization began recording history. The storms have become a quiet bridge connecting countless generations through one shared experience beneath the tropical night. Even now, researchers continue uncovering new details about the phenomenon. Advances in computer modeling allow meteorologists to simulate the complex movement of air across the Maracaibo Basin with increasing accuracy. Improved satellite instruments measure lightning activity in extraordinary detail, while sophisticated weather stations collect enormous amounts of atmospheric data every day. Each new observation helps scientists refine their understanding of how this remarkable natural system functions. Yet for every question that receives an answer, another often emerges. Small variations in seasonal rainfall, subtle changes in wind circulation, and complex interactions within towering storm clouds continue providing new mysteries to explore. Rather than diminishing the wonder of Catatumbo Lightning, scientific knowledge has revealed just how intricate and beautifully balanced the atmosphere truly is. Perhaps that is the greatest gift offered by places such as Lake Maracaibo. They remind us that our planet still possesses landscapes capable of inspiring both curiosity and humility at the same time. We may understand far more about thunderstorms today than earlier generations ever could, yet standing beneath these glowing skies still evokes the same sense of awe that people have felt for thousands of years. Science allows us to appreciate the remarkable processes creating the phenomenon, while the experience itself reminds us that understanding does not diminish beauty. If anything, it deepens it. Knowing how countless natural forces cooperate to produce these endless flashes only makes the spectacle more extraordinary. Beneath the warm tropical night of Venezuela, the atmosphere continues performing one of its greatest masterpieces, patiently reminding anyone fortunate enough to witness it that nature's most remarkable wonders are often created not through a single dramatic event, but through countless invisible processes working together in perfect harmony. Although Catatumbo Lightning is unlike any other weather phenomenon on Earth, it also reminds us that our planet is filled with remarkable places where geography quietly shapes the forces of nature. Towering mountain ranges redirect winds, vast oceans store tremendous amounts of heat, deserts create shimmering waves of rising air, and polar regions influence global weather far beyond their icy landscapes. Lake Maracaibo simply represents one of the most extraordinary examples of these natural relationships. Here, every evening becomes a demonstration of how closely connected the Earth systems truly are. The atmosphere cannot be separated from the land below it, nor can the lake be separated from the mountains surrounding it. There is something especially beautiful about the predictability of this phenomenon. Human beings often associate excitement with surprise, yet Catatumbo Lightning proves that repetition can be just as remarkable. The storms return not because they are unpredictable, but because nature has created conditions that reliably encourage them to form again and again. Evening follows afternoon. Warm air rises from the lake. Cooler air descends from the mountains. Towering clouds gather above the basin, and before long, the first flashes spread across the horizon. This dependable rhythm transforms the storms into something almost comforting. They become part of the nightly heartbeat of the landscape, arriving with such consistency that generations of local families have come to measure evenings not by the clock, but by the first distant glow appearing above the lake. For scientists, this remarkable consistency provides an invaluable opportunity. Every thunderstorm acts as another lesson written across the sky. Instruments quietly record changes in temperature, humidity, wind speed, atmospheric pressure, and electrical activity, while satellites observe the storms from far above the Earth. Over many decades, These observations have created an extraordinary record documenting one of the world's most persistent atmospheric phenomena. Unlike rare events that may occur only once every several years, Catatumbo Lightning offers researchers repeated opportunities to test ideas, compare observations, and improve their understanding of how thunderstorms develop. Every evening becomes another chapter in an ongoing scientific story, one that continues growing with each passing season. Yet despite all of this remarkable technology, the experience of simply watching the storms remains wonderfully timeless. Imagine sitting quietly aboard a small boat, drifting gently across the warm waters of Lake Maracaibo. The air is soft and humid, carrying the scent of fresh water and nearby wetlands. The surrounding mountains have become dark silhouettes beneath a sky filled with stars. Then, almost silently, the horizon begins glowing once again. One brilliant flash spreads through the distant clouds, followed by another only moments later. Soon the entire skyline pulses with light, as though enormous lanterns have been hidden inside the storm itself. Their reflections shimmer across the calm lake, doubling the beauty of the display, while the tropical night remains otherwise peaceful and still. It is easy to understand why so many visitors describe the experience not simply as exciting, but as deeply calming. There is a rhythm to the storms, a gentle repetition that encourages quiet observation rather than hurried excitement. Perhaps that peaceful rhythm explains why Catatumbo Lightning has inspired such fascination for so many centuries. Long before anyone understood atmospheric electricity, people gathered beneath these same skies to watch the glowing horizon. They may not have known about cumulonimbus clouds, electrical charge separation, or satellite observations, yet they recognized they were witnessing something extraordinary. Today we possess far greater scientific knowledge, but the emotional experience remains remarkably similar. Knowledge has not taken away the mystery. Instead, it has shown us just how many invisible processes must work together before a single flash of lightning can appear. As another tropical evening settles across Lake Maracaibo, the atmosphere once again begins preparing for its nightly performance. Warm water continues releasing moisture into the air. Gentle winds drift down from the surrounding mountains. Towering storm clouds slowly build above the basin, while countless tiny ice crystals and droplets begin their invisible collisions high overhead. The electrical tension grows steadily stronger until, at last, another brilliant flash races across the darkness. Then another follows, and another after that, continuing a rhythm that has endured for countless generations. Hidden within the warm nights of Venezuela, the sky continues telling one of Earth's most extraordinary stories, written not with words, but with endless flashes of light stretching across the horizon. One final question has intrigued people for generations. Why has no other place managed to duplicate exactly what happens above Lake Maracaibo? After all, there are many warm tropical lakes around the world. There are mountain ranges in countless countries, humid wetlands stretching across entire continents, and powerful thunderstorms occurring almost every day somewhere on Earth. Yet nowhere else do these ingredients combine with the same remarkable reliability. The answer appears to lie in the extraordinary precision with which the landscape surrounding Lake Maracaibo has been arranged by nature. The basin is positioned at just the right latitude to receive abundant tropical warmth throughout the year. The surrounding mountains are placed in ways that guide cool evening air toward the lake. The broad expanse of warm water continually supplies moisture, while the nearby wetlands enrich the atmosphere even further. Individually, none of these features would be enough to create Catatumbo Lightning. Together, they form one of the most remarkable natural weather systems on the planet. Scientists sometimes describe this as a perfect atmospheric recipe. Just as baking bread requires the proper balance of flour, water, yeast, and heat, the skies above Lake Maracaibo depend upon an equally careful combination of natural ingredients. If the lake were significantly smaller, there might not be enough moisture available. If the surrounding mountains were lower, cooler air would descend differently into the basin. If the tropical climate were less humid, towering storm clouds might never reach the heights necessary to generate such intense electrical activity. Every part of the landscape contributes something essential. The result is a phenomenon that appears almost miraculous until one begins appreciating the countless natural forces quietly cooperating behind the scenes. Even then, the remarkable precision with which these elements continue working together night after night remains deeply impressive. The atmosphere itself is often compared to an enormous engine, constantly moving energy around the planet. Warm air rises near the equator, while cooler air sinks toward the poles. Oceans transport heat across vast distances through powerful currents. Winds carry moisture from one continent to another, and storms help redistribute energy throughout the atmosphere. Catatumbo Lightning represents one small yet spectacular example of this much larger planetary system. The storms above Lake Maracaibo may seem isolated, but they are connected to atmospheric circulation extending far beyond Venezuela. The same physical laws governing these nightly thunderstorms also influence weather patterns across every ocean, mountain range, and continent on Earth. By studying one remarkable corner of the world, scientists gain insights into processes shaping weather everywhere. This larger perspective helps explain why Catatumbo Lightning remains so valuable to atmospheric research. It allows scientists to observe powerful thunderstorms developing under conditions that repeat with unusual regularity. Every evening provides another opportunity to compare computer models with real observations. Every season adds new information about how rainfall, humidity, and regional wind patterns influence storm activity. Over many decades, these observations accumulate into an extraordinarily rich scientific record that continues improving our understanding of the atmosphere. Although weather often appears unpredictable from day to day, places like Lake Maracaibo reveal that nature also follows dependable patterns when geography, climate, and atmospheric circulation remain in careful balance. It is one of the reasons researchers from around the world continue paying close attention to this remarkable region. For travelers fortunate enough to witness Catatumbo Lightning, however, the experience rarely centers upon scientific measurements or atmospheric theories. What remains strongest in memory is usually the feeling of standing beneath a sky unlike any they have ever seen before. They remember the warm evening breeze drifting across the water, the distant silhouettes of mountains surrounding the lake, the quiet sounds of insects rising from nearby wetlands, and then the first brilliant flash spreading silently across the horizon. They remember how quickly one flash became dozens, then hundreds, until the storm seemed almost alive with light. Long after technical details fade from memory, those images remain, glowing as vividly as the lightning itself. It is remarkable to think that somewhere over Lake Maracaibo, this very moment, another evening is likely unfolding much as it has for centuries. The tropical sun has already warmed the lake. Moisture has quietly risen into the humid air throughout the day. Gentle mountain winds are beginning their slow descent into the basin as darkness spreads across the landscape. Towering cumulonimbus clouds continue climbing into the atmosphere, carrying within them the invisible electrical charges that will soon illuminate the night. Then, almost without warning, the first brilliant flash will once again spread across the Venezuelan sky, followed by another and another, continuing one of nature's most extraordinary traditions. Hidden from much of the world, yet faithfully returning night after night, Catatumbo Lightning reminds us that our planet still holds places where the impossible seems almost ordinary, and where the greatest wonders reveal themselves only after the stars begin to shine. Although Catatumbo Lightning is often described as the place where lightning never stops, perhaps the more remarkable truth is that the phenomenon has never stopped inspiring curiosity. Every generation has looked toward these glowing skies and asked the same simple questions. Why here? Why so often? How can one place produce such extraordinary storms while the rest of the world experiences lightning only occasionally? Those questions first belong to the indigenous communities who watched the horizon long before history was written. Later they were asked by European explorers, sailors navigating the Caribbean, naturalists attempting to describe the strange phenomenon, and modern atmospheric scientists using satellites orbiting hundreds of miles above the Earth. The questions have remained remarkably consistent, even as the tools used to answer them have changed beyond recognition. One of the most encouraging aspects of this continuing research is that it demonstrates how science is never truly finished. There was a time when people believed lightning was simply an unpredictable force of nature beyond explanation. Later generations discovered that electrical charges developing inside storm clouds produced the brilliant flashes lighting the sky. Still later, meteorologists uncovered the important roles played by geography, humidity, mountain winds, and atmospheric circulation. Yet even today, researchers continue refining computer models, collecting new observations, and comparing data gathered over many decades. Every answer leads naturally to another question, not because earlier discoveries were incorrect, but because nature is often far more intricate than it first appears. Catatumbo Lightning continues reminding scientists that the atmosphere is one of the most complex systems on our planet, shaped by countless invisible interactions unfolding simultaneously above our heads. Perhaps this is why places like Lake Maracaibo remain so important. They encourage people to remain curious about the natural world. In an age when maps seem complete and satellites photograph nearly every corner of the Earth, it is easy to imagine that there are few mysteries left to explore. Yet standing beside the lake, as endless flashes illuminate the clouds overhead, quickly reminds us that understanding a place is very different from simply knowing where it is. We may know its location with remarkable precision. We may understand much of the atmospheric science responsible for the storms, but the experience itself continues inspiring the same quiet wonder that earlier generations felt centuries ago. Knowledge has not diminished the beauty of Catatumbo Lightning. Instead, it has revealed just how extraordinary the natural processes behind it truly are. As darkness deepens over the Maracaibo Basin, the familiar rhythm quietly continues. Warm air rises from the broad surface of the lake, carrying invisible moisture high into the tropical atmosphere. Cooler air slips gently down from the surrounding mountains, meeting the rising warmth above the basin, exactly as it has for countless generations. Towering storm clouds continue growing toward the upper atmosphere, while countless tiny ice crystals and droplets collide within them, slowly separating electrical charges until another brilliant flash suddenly races across the night sky. Seconds later, another follows, then another beyond that, each illuminating the clouds before gently fading back into darkness. Across the still waters of the lake, shimmering reflections briefly mirror the display before disappearing into the quiet tropical night. The atmosphere continues performing its timeless cycle with remarkable patience, asking for nothing more than the landscape that has supported it for centuries. Somewhere tonight, along the quiet shores of Lake Maracaibo, a child may look toward the glowing horizon with the same sense of amazement experienced by generations before. A fisherman may pause while preparing his boat, watching familiar flashes brighten the distant clouds. A scientist may quietly monitor instruments recording another evening of extraordinary atmospheric activity. A traveler may stand silently beside the water, realizing they are witnessing one of the rarest natural spectacles on Earth. It is a story written not in books or monuments, but across the tropical heavens themselves, repeating with such extraordinary consistency that it has become one of the defining natural wonders of our planet, quietly reminding us that even today, the Earth still possesses places capable of filling us with genuine wonder. For centuries, people living around Lake Maracaibo have learned to measure time not only by the rising and setting of the sun, but also by the dependable rhythm of the evening storms. In many parts of the world, weather is something that interrupts daily life. A thunderstorm arrives unexpectedly, people seek shelter for a short while, and before long, the skies begin clearing once again. Around the Catatumbo region, the relationship is very different. The storms are not unexpected visitors, they are familiar neighbors. Their arrival after sunset has become such a recognizable part of the landscape that countless generations have simply accepted them as another feature of home. Children grow up understanding that the distant horizon often glows after dark. Elders pass along stories of evenings spent watching the flashes from wooden docks or small fishing boats. Visitors may stare upward in amazement, but local families often view the spectacle with the quiet familiarity that comes from seeing something beautiful throughout an entire lifetime. That familiarity, however, never seems to erase the sense of wonder. Even people who have watched the storms for decades often pause to admire an especially active evening when the entire horizon seems alive with light. Other evenings become grand performances in which the atmosphere seems determined to display every imaginable pattern of lightning. Branching bolts spread sideways through the clouds, while broad sheets of light briefly reveal enormous storm towers stretching high into the upper atmosphere. At times, several different sections of the sky illuminate almost simultaneously, creating the impression that multiple storms are performing together across the basin. No matter how often someone has witnessed Catatumbo Lightning, each display remains unique because the atmosphere is constantly reshaping itself in subtle ways. Meteorologists often describe thunderstorms as living systems because they continually grow, mature, weaken, and rebuild while interacting with the surrounding atmosphere. Catatumbo Lightning provides an especially clear example of this continual evolution. During the first hours after sunset, individual storm cells may begin forming over different parts of the basin as warm air rises unevenly from the lake and surrounding wetlands. As the evening progresses, these individual storms sometimes merge into larger complexes capable of producing even more impressive electrical displays. New clouds develop while older ones gradually lose energy, creating an ever-changing mosaic of activity spread across the night sky. Although observers standing along the shore may perceive one enormous storm stretching from horizon to horizon, the atmosphere is actually performing countless smaller processes simultaneously, with different sections of the storm constantly growing, fading, and reforming throughout the night. The tremendous height reached by these cumulonimbus clouds is another reason the storms appear so dramatic. Some extend more than 10 miles into the atmosphere, reaching altitudes where temperatures remain far below freezing, despite the tropical warmth experienced at the surface. Within these towering structures, countless tiny ice crystals, droplets of supercooled water, and small hailstones move continuously through powerful updrafts and downdrafts. Every collision contributes in some small way to the gradual separation of electrical charges that eventually produces lightning. The lightning itself lasts only a fraction of a second, yet it represents the culmination of atmospheric processes that have been quietly developing for hours. Researchers studying thunderstorms often emphasize that lightning is only one visible expression of the enormous energy constantly circulating through Earth's atmosphere. Every day, sunlight warms the planet unevenly, creating differences in temperature that drive winds, storms, and weather systems across the globe. Tropical regions receive tremendous amounts of solar energy throughout the year, making them especially favorable environments for vigorous thunderstorm development. Lake Maracaibo occupies one of these warm tropical regions, yet it possesses the additional geographical advantages needed to concentrate that atmospheric energy with unusual efficiency. Rather than allowing moisture and warm air to disperse randomly across the landscape, the surrounding mountains help organize these ingredients into a repeating nightly pattern. It is as though nature has gently guided the atmosphere toward one preferred location, allowing the same remarkable performance to unfold again and again. Another fascinating aspect of Catatumbo Lightning is the remarkable distance from which the storms can sometimes be seen. On exceptionally clear nights, the repeated flashes have historically been visible from many miles away across the Caribbean Sea. Before electronic navigation, this dependable glow became an invaluable point of reference for experienced sailors approaching the coast of Venezuela. Unlike the rotating beam of a traditional lighthouse, which briefly sweeps across the horizon before disappearing again, Catatumbo Lightning often provides repeated bursts of illumination throughout the night. Mariners learned that if they continued sailing toward the distant flashes, they were approaching the entrance to Lake Maracaibo. It is one of the few examples in history where a naturally occurring weather phenomenon served as such a dependable navigational aid. The atmosphere itself became a guide, helping generations of sailors find their way long before modern technology transformed navigation forever. Historical accounts from the colonial period occasionally mention nights when the horizon seemed almost continuously illuminated. Although descriptions naturally varied according to the observer, many writers expressed genuine amazement at the persistence of the storms. Some compared the flashes to distant fires burning beyond the mountains, while others described the clouds as glowing lanterns suspended high above the earth. Without the benefit of modern atmospheric science, these observers relied entirely upon careful observation and personal experience. Their writings provide valuable glimpses into how extraordinary Catatumbo Lightning appeared to people encountering it for the first time centuries ago. Reading these historical descriptions today reveals something striking. Although our scientific understanding has advanced enormously, the emotional reaction has changed very little. People still experience the same sense of awe when standing beneath those remarkable skies. There is also an important reminder hidden within the story of Catatumbo Lightning about the value of protecting unique natural environments. The storms exist because of an intricate balance involving Lake Maracaibo, its surrounding wetlands, nearby mountain ranges, and the tropical atmosphere above them. Every part of that landscape contributes to the conditions supporting the phenomenon. Healthy wetlands continue releasing moisture into the air. Rivers flowing from the Andes replenish the basin with fresh water. Forests and marshes participate in the larger water cycle that influences regional humidity. Understanding these connections encourages greater appreciation for the entire ecosystem, rather than focusing only on the lightning itself. The glowing skies above the lake are, in many ways, the visible expression of countless natural processes working together below. Perhaps this is why Catatumbo Lightning feels less like a simple weather event and more like the signature of an entire landscape. The lightning belongs to the lake, but it also belongs to the mountains, the wetlands, the rivers, and the warm tropical climate surrounding them all. Remove any one piece, and the nightly spectacle might no longer exist as we know it. Every brilliant flash reminds us that nature rarely creates its greatest wonders through a single cause. Instead, extraordinary beauty often emerges when many ordinary processes cooperate over immense periods of time. For thousands of years, Lake Maracaibo has quietly demonstrated that lesson every evening as darkness settles across the basin and the first familiar flashes once again begin painting the Venezuelan sky with light. One of the most interesting aspects of Catatumbo Lightning is that it reminds us how much patience is required to truly understand the natural world. Many scientific discoveries happen because researchers spend years, sometimes even decades, observing the same place over and over again. A single evening beside Lake Maracaibo might reveal an unforgettable lightning display, but it cannot explain why one night produces hundreds of flashes while another remains comparatively quiet. Only by carefully recording weather conditions over many seasons can patterns begin to emerge. Scientists compare rainfall, temperatures, humidity, wind direction, and atmospheric pressure, searching for subtle relationships that would otherwise remain hidden. The work requires remarkable dedication because nature rarely reveals all of its secrets at once. Instead, understanding grows slowly, built from countless observations gathered one day at a time, much like individual drops of rain eventually filling the Great Lake itself. This patient approach has gradually revealed that Catatumbo Lightning is not an isolated event, but part of a much larger atmospheric system extending across northern South America. Moisture arriving over Lake Maracaibo often begins its journey hundreds of miles away. Warm air flowing inland from the Caribbean Sea carries enormous quantities of water vapor that continue moving across the landscape throughout the day. Rivers descending from the Andes contribute fresh water to the basin, while countless wetlands release additional moisture back into the atmosphere through evaporation and transpiration. By the time evening arrives, the air above the lake has become richly saturated with invisible water vapor gathered from an enormous region. The storms we witness above the basin therefore represent the combined work of landscapes extending far beyond the shoreline itself. Mountains, forests, rivers, marshes, and tropical seas all quietly contribute to the spectacle, long before the first cloud begins towering into the evening sky. Because these storms occur so frequently, they have also provided researchers with an exceptional opportunity to study lightning itself. Although every child quickly learns that lightning is dangerous, the precise physics behind each flash remains remarkably complex. A lightning bolt does not simply appear all at once. Instead, it develops through a rapid series of electrical events, unfolding far too quickly for the human eye to follow. A faint channel of electricity known as a stepped leader begins descending from the cloud in tiny invisible segments, searching for the easiest path toward the ground or another region of opposite electrical charge. As it approaches its destination, an upward streamer rises to meet it. Specialized high-speed cameras have shown that what appears to us as one simple bolt is actually an astonishing sequence of electrical events unfolding within mere thousandths of a second. Even thunder tells its own fascinating story. Many people imagine thunder as a separate event following lightning, but in reality, the two are inseparable. The brilliant electrical discharge instantly heats the surrounding air to temperatures approaching 30,000 degrees Celsius, far hotter than the surface of the sun. This sudden heating causes the air to expand with explosive speed, sending powerful pressure waves racing outward in every direction. Those pressure waves are what our ears perceive as thunder. Because light travels vastly faster than sound, we always see the lightning before hearing its thunder, unless the strike occurs extremely close by. Around Lake Maracaibo, observers watching distant storms often witness dozens of silent flashes reflected across the clouds, while the thunder arrives much later as a gentle rumble rolling across the water. Sometimes the storms remain so distant that the sound fades before reaching the shoreline at all, leaving only the mesmerizing display of light dancing across the tropical night. The changing seasons also bring subtle differences to the appearance of the storms themselves. During periods of especially abundant rainfall, towering cumulonimbus clouds often grow larger and remain active for longer periods, producing broad curtains of lightning stretching across the horizon. During relatively drier months, storms may become more isolated, with individual cloud towers producing distinct flashes separated by darker intervals between them. Visitors fortunate enough to witness the phenomenon during different times of the year quickly discover that no two evenings ever appear exactly alike. The underlying rhythm remains familiar, yet every performance possesses its own personality, ensuring that even lifelong residents continue finding new details to admire. As technology has improved, researchers have begun comparing Catatumbo Lightning with other regions famous for intense thunderstorm activity. Central Africa, parts of the Himalayas, and portions of the southeastern United States all experience impressive concentrations of lightning under certain conditions. Yet when scientists analyze the consistency with which electrical storms return to Lake Maracaibo, the Venezuelan phenomenon continues standing apart. This dependable concentration of activity has made the region one of the most valuable natural laboratories available for studying atmospheric electricity. Every evening offers another opportunity to observe processes that elsewhere might occur only occasionally or under far less predictable circumstances. Perhaps one of the greatest joys of learning about Catatumbo Lightning is realizing how beautifully interconnected the story becomes the deeper we explore it. What begins as a simple question about lightning gradually expands into a story about geography, climate, mountains, lakes, rivers, wetlands, atmospheric physics, history, exploration, navigation, and human curiosity itself. Each subject naturally leads to another because none of them exists in complete isolation. The mountains influence the winds shape the clouds produce the lightning inspires explorers, sailors, scientists, photographers, and travelers. In turn, their observations deepen our appreciation for the remarkable landscape that made everything possible in the first place. Few natural phenomena demonstrate so clearly how many different branches of science and history can converge in a single location. As another peaceful evening settles across Lake Maracaibo, the familiar cycle quietly begins once more. Warm tropical air continues rising from the broad surface of the lake, carrying invisible moisture toward the gathering clouds. Cool mountain breezes descend through valleys that have guided evening winds for countless generations. Towering storm clouds slowly expand into the darkening sky, while unseen electrical charges continue separating high within their icy summits. As remarkable as Catatumbo Lightning appears from the ground, the view from high above the earth tells an equally fascinating story. Satellites passing overhead do not see individual villages, fishing boats, or people standing along the shoreline, looking toward the glowing horizon. Instead, they observe the atmosphere itself as an enormous living system. Every evening, as darkness spreads across northern South America, instruments aboard these satellites begin detecting bursts of electrical activity concentrated over the Maracaibo Basin. From hundreds of miles above the Earth, the storms appear almost like a heartbeat, pulsing steadily in the same familiar location, while weather systems continue moving across the surrounding continent. These satellite observations have helped scientists appreciate just how unusual the phenomenon truly is. Around the world, thunderstorms constantly form, mature, and disappear. Some develop over tropical rainforests, others above warm oceans, and still others across broad plains where afternoon sunshine heats the land. Most of these storms drift with prevailing winds before gradually weakening as their energy is exhausted. Catatumbo Lightning behaves differently. Although the individual storm clouds continually change, the overall pattern remains centered within the same remarkable geographical setting. It is not one permanent storm lingering endlessly above the lake, but rather a succession of thunderstorms repeatedly forming under nearly identical atmospheric conditions. Each evening brings new clouds, new electrical charges, and new flashes of lightning, yet together they create the impression of one continuous natural performance unfolding across the Venezuelan sky. One reason this repeating pattern has endured for so long is that the geography surrounding Lake Maracaibo changes only very slowly over geological time. Mountains that guide the evening winds today were already standing long before human civilization developed in this part of South America. Rivers flowing into the basin have carved their valleys over immense spans of time, gradually shaping the wetlands and floodplains that now contribute moisture to the atmosphere. Even the broad outline of the lake itself has evolved over thousands of years as rivers deposited sediment and changing sea levels influenced its connection with the Caribbean. Although these changes occur far too slowly for any individual person to notice, they remind us that Catatumbo Lightning is the product of a landscape patiently shaped by nature across countless generations. The nightly storms belong not only to today's Venezuela, but also to the deep geological history that created the basin in the first place. The Andes Mountains deserve special appreciation within this story because they are among the longest mountain ranges on Earth. Stretching for thousands of miles along the western edge of South America, they influence weather patterns across an enormous portion of the continent. Snow-covered summits rise high above tropical forests, while glaciers, rivers, and fertile valleys support a remarkable diversity of life. Near Lake Maracaibo, the northern branches of the Andes help create the enclosed basin that makes Catatumbo Lightning possible. Every evening, cool air begins descending from these elevated slopes toward the warmer lowlands below. It is a movement so gentle that people standing beside the lake rarely notice it directly. Yet without this steady downhill flow, the atmosphere would behave very differently. The mountains quietly guide the winds with the same reliability that riverbanks guide flowing water, demonstrating once again how profoundly the shape of the land influences the weather above it. Another fascinating feature of the region is the tremendous amount of water constantly moving through the landscape. Rain falling on distant mountain slopes eventually finds its way into streams and rivers that empty into Lake Maracaibo. Along the journey, some water nourishes forests, some supports wetlands rich with wildlife, and some returns to the atmosphere through evaporation long before reaching the lake. Once the water enters the basin, sunlight begins lifting tiny amounts back into the air throughout every daylight hour. This endless circulation is part of the global water cycle connecting oceans, rivers, lakes, clouds, rainfall, and groundwater across the entire planet. Catatumbo Lightning exists because this cycle operates with extraordinary efficiency in one particular corner of Venezuela, continually replenishing the atmosphere with the moisture needed to sustain the nightly storms. Even the clouds themselves display remarkable variety throughout an active evening. Some remain compact towers producing occasional flashes before gradually dissolving into the darkness. Others expand into vast cloud complexes stretching across large portions of the horizon, their upper surfaces spreading outward as powerful updrafts continue feeding them from below. Within these immense structures, countless smaller processes unfold simultaneously. New cloud towers grow while older ones weaken. Fresh electrical charges accumulate as previous ones are released through brilliant lightning. Rain falls from one section of the storm while another continues building higher into the atmosphere. To someone observing from the shoreline, the display appears seamless, yet the clouds are constantly evolving, rebuilding themselves in ways that reflect the endlessly changing nature of the atmosphere. Perhaps this continual renewal is one of the reasons Catatumbo Lightning remains so captivating. The storms never repeat themselves exactly, yet they never seem completely unfamiliar either. Every evening offers another variation on the same remarkable theme. The mountains remain patiently surrounding the basin. The lake continues releasing warmth into the humid tropical air. Moisture rises, clouds grow, electrical charges separate, and brilliant flashes once again illuminate the darkness above Lake Maracaibo. Although the science behind Catatumbo Lightning continues advancing, there remains an important difference between understanding a natural phenomenon and truly experiencing it. Scientific papers can explain atmospheric instability, satellite measurements can count millions of lightning flashes, and computer models can simulate the movement of warm and cool air across the Maracaibo Basin. Yet none of these descriptions fully capture the feeling of standing beside the lake as darkness slowly settles over the water. The tropical evening grows quiet. The last traces of orange sunlight fade behind distant mountains, leaving the horizon wrapped in deep shades of blue. A gentle breeze carries the scent of fresh water and wetlands across the shoreline. Everything seems perfectly peaceful. Then, without warning, the clouds briefly glow from within. In that moment, science and wonder exist comfortably side by side. Understanding how the storms form only deepens the appreciation of watching them unfold. Many visitors are surprised by the immense scale of the landscape itself. Lake Maracaibo stretches so far that in many places, the opposite shoreline is difficult to distinguish beneath the evening sky. During daylight, the broad expanse of water reflects drifting clouds and brilliant tropical sunshine, giving little hint of what will happen after sunset. Fishing boats leave gentle wakes behind them as they cross the calm surface, while birds circle overhead, searching for their next meal. Along the distant shoreline, villages and larger cities continue their daily routines, connected by the great body of water that has supported life here for countless generations. It is a landscape that appears peaceful, productive, and familiar. Only when darkness arrives does it reveal the extraordinary atmospheric performance that has made this corner of Venezuela unlike anywhere else on Earth. The mountains surrounding the basin contribute more than simply dramatic scenery. They create countless smaller valleys, ridges, and passes through which cool evening air gradually descends after the heat of the day begins fading. Although these air movements are invisible, they represent one of the quiet engines driving the nightly storms. Meteorologists often compare air to flowing water because both naturally follow the shape of the landscape. Just as streams gather within valleys before joining larger rivers, cooler mountain air slowly collects and moves downhill toward the warmer basin below. This gentle flow strengthens the upward movement of the warm, moisture-rich air rising from Lake Maracaibo, encouraging storm clouds to grow taller and more powerful as evening progresses. The mountains therefore participate in every lightning display, even though they never produce a single flash themselves. Their influence is constant, silent, and remarkably dependable. One particularly beautiful aspect of Catatumbo Lightning is the variety of colors occasionally visible within the storms. While lightning is often imagined as brilliant white, careful observers sometimes notice subtle shades of blue, violet, or pale gold, depending upon the thickness of the surrounding clouds, the amount of moisture in the atmosphere, and the distance from the observer. Reflected through layers of rain and vapor, the flashes can briefly transform the clouds into enormous glowing sculptures suspended high above the lake. The water below captures these changing colors with remarkable clarity, creating shimmering reflections that seem almost as vivid as the storm itself. During especially active evenings, the boundary between sky and water begins to blur as each flash is mirrored across the calm surface, making it appear as though two storms are unfolding simultaneously, one above and one below. The remarkable frequency of the lightning also encourages patience in a way that few other natural spectacles do. Unlike a shooting star that appears only for a fleeting instant, or a rare eclipse lasting just a few minutes, Catatumbo Lightning invites people to slow down and simply observe. There is no need to rush, because another flash is almost always waiting just beyond the darkness. One burst of light fades, followed by a brief moment of quiet, before another illuminates an entirely different section of the clouds. This steady rhythm creates an experience that feels almost meditative. The mind gradually stops anticipating the next flash and instead settles into the gentle pattern established by the atmosphere itself. Many visitors later describe spending hours watching the storms without realizing how much time had passed, carried along by the quiet repetition of light, darkness, and reflection upon the still waters of the lake. Perhaps this peaceful rhythm explains why Catatumbo Lightning has remained so memorable throughout history. It is not simply the power of the storms that leaves an impression, but the extraordinary balance between energy and tranquility. The atmosphere releases immense electrical forces high above the earth, while the landscape below often remains calm and undisturbed. The lake reflects each brilliant flash without breaking its gentle surface. Night birds continue calling from nearby wetlands, insects maintain their evening chorus, and soft breezes drift across the water exactly as they did before the storms began. Nature somehow combines immense power with remarkable serenity, reminding us that strength and calm are not always opposites. Sometimes they exist together within the same landscape, creating experiences that feel both exhilarating and deeply restful. As another evening quietly unfolds across Lake Maracaibo, the ancient cycle begins once more. Warm tropical waters continue releasing invisible moisture into the atmosphere. Cool mountain air slips gently down through valleys shaped over millions of years. Towering storm clouds climb toward the upper atmosphere, carrying within them the electrical energy that will soon illuminate the darkness. Then, as though following a timeless rhythm written into the landscape itself, another brilliant flash spreads across the Venezuelan sky. It is followed by another and another beyond that, each one adding another moment to a story that has been unfolding above these waters for countless generations. Long before anyone understood the science, long before anyone gave the phenomenon a name, the sky above Lake Maracaibo was already telling this remarkable story through light alone, and tonight it continues exactly as it always has. The story of Catatumbo Lightning also reminds us that some of the world's greatest natural wonders remain surprisingly hidden from everyday conversation. Ask someone to name famous waterfalls, and they might mention Niagara or Victoria Falls. Ask about towering mountains, and names like Everest or Kilimanjaro often come to mind. Volcanoes, deserts, coral reefs, and great rivers all have places firmly established within popular imagination. Yet mention a lake where the night sky erupts with lightning on hundreds of nights each year, and many people are hearing about it for the very first time. That quiet obscurity somehow makes the phenomenon even more remarkable. It is not hidden because it lacks beauty or scientific importance. Instead, it simply exists in a corner of the world that relatively few travelers have experienced firsthand. Every evening, while much of the world sleeps or goes about its ordinary routines, the skies above northwestern Venezuela quietly produce one of Earth's greatest atmospheric spectacles, with little fanfare beyond the communities fortunate enough to witness it regularly. There is something deeply refreshing about discovering places like this. They remind us that our planet still holds landscapes capable of surprising even those who have spent a lifetime studying geography or exploring nature. Modern maps may leave very few blank spaces, yet they cannot fully convey the character of a place. A satellite image of Lake Maracaibo reveals its shape, the surrounding mountains, and the rivers flowing into the basin. but it cannot capture the feeling of warm evening air drifting across the water as darkness slowly arrives. It cannot reproduce the anticipation that builds while distant clouds quietly rise higher into the tropical sky. Nor can it prepare someone for the first brilliant flash that suddenly transforms the horizon into a glowing panorama of light. Some places must be experienced with patience rather than simply located on a map. And Catatumbo Lightning is surely one of them. The more carefully we examine this phenomenon, the more it reveals about the extraordinary balance that exists throughout the natural world. Every part of the landscape contributes something essential. The Caribbean supplies warmth and moisture that move inland with tropical air. The Andes guide cool evening winds toward the basin. Rivers nourish wetlands rich with life, while Lake Maracaibo stores solar energy throughout the day before gradually releasing it after sunset. No single feature deserves all the credit, because the spectacle depends upon their cooperation. It is a beautiful reminder that nature often produces its greatest achievements not through one dominant force, but through countless smaller forces working together in remarkable harmony. Perhaps this is why Catatumbo Lightning has inspired so many different kinds of observers throughout history. To local communities, it became a familiar companion of the evening. To sailors, it served as a dependable beacon guiding ships across dark waters. To explorers, it represented one of the great mysteries of the New World. To photographers, it offers an endless source of dramatic beauty. To meteorologists, it provides an invaluable opportunity to study atmospheric electricity under unusually consistent conditions. Each group has looked upon the same glowing skies, yet found something slightly different waiting there. The phenomenon seems almost perfectly suited to every kind of curiosity, because it exists at the meeting point of science, history, geography, culture, and natural beauty. Few places manage to unite so many different stories within a single landscape. Even after spending hours learning about Lake Maracaibo and its remarkable storms, there remains a comforting sense that the phenomenon cannot be completely reduced to numbers or scientific explanations alone. We can measure humidity, calculate wind speeds, monitor lightning frequency, and model atmospheric circulation with increasing precision. All of these discoveries deepen our understanding, yet they do not replace the quiet emotional experience of watching the sky repeatedly burst into light above a peaceful tropical lake. Knowledge and wonder continue to exist side by side, each enriching the other. Every brilliant pulse of light reminds us that invisible forces have been quietly working together throughout the entire day, preparing for a performance lasting only fractions of a second before beginning the cycle once again. Thank you for joining me on tonight's journey to one of the world's most extraordinary and least known natural wonders. I hope our visit to the glowing skies of Lake Maracaibo has filled your imagination with peaceful landscapes, fascinating discoveries, and a deeper appreciation for the remarkable forces quietly shaping our planet every single day. As the distant lightning continues dancing across the Venezuelan horizon and the warm tropical night settles gently over the calm waters below, may your own evening become just as peaceful. Sleep well, dream deeply, and I'll see you next time here on the Sleepy Mind channel.